All right, here we go. Question number 8 from our 1316 homework number 2 in MyLab Math. Wants us to graph the following function, show at least 2 cycles, use the graph to determine the domain and range of the function. So the first thing I'm going to do is recopy this equation over here. We've got y equals cotangent 1/13 x. And a couple of things to note just real quick. Our A is 1, positive 1, and our B is 1/13. A couple of things to note there. Okay, so now let's go find some stuff. Or actually, let's go through the 4-step process of graphing a tangent or cotangent function. Okay, step number 1 is to get consecutive asymptotes. If you have a cotangent, that means that your angle theta is going to be bound between 0 and pi respectively. That means that your graph is going to exist between 0 and pi for any theta that fits the angle that you're given here, okay? So the 0 and pi will be 2 consecutive asymptotes depending on what theta is. And so our theta is 1/13 x. So we're going to have to plug in for theta and then solve for x to find 2 consecutive asymptotes. And we're going to solve for x by multiplying by 13. So to get rid of the fraction 1/13, you would need to multiply by 13. 13 times 1/13 would be 13 over 13, which is 1, which gets x by itself. And so this will be 13 pi, and 0 times anything is still 0. So this is where you're going to have consecutive asymptotes at 0, and then the next asymptote will be at 13 pi. Okay, that's step number 1. Step number 2, you're going to have an x-intercept halfway between the intercepts, not the intercepts, the asymptotes. Made a few too many videos today, I think. X-intercept, you're going to have an x-intercept halfway between the asymptotes. And then step number 3. Since we're dealing with cotangent, we're going to say at the first and third quarters, we're going to have y values of a and negative a respectively, okay? And I'll explain what that means in just a second. Step number 4, which is the last step, is connect the dots. So let's get us a coordinate system laid out here. And let's demonstrate how the 4 steps lead us to the graph, okay? So we're going to say right here that our first asymptote is going to be at 0, and the very next asymptote will be at 13 pi. So if I lay that out with red, we're going to have an asymptote at 0, and then somewhere over here at 13 pi, we'll have another asymptote. So can you see that those consecutive asymptotes are 13 pi apart? So if I go another 13 pi, 13 and 13, that's 26 pi. I'll have another asymptote. Step number 2, x-intercept halfway between the asymptotes. So right in the middle of the asymptotes, we're going to have x-intercepts. And if you think about what is half of 13, that is, what is that, 6.5? 6.5, so that's going to be 13 pi over 2. And then 6, 19, 28, 29 pi over 2. If I do the math correctly there. 13 and 13 is 26 over 2 is 13. And then another 13 would be 39. 39 pi over 2. And then another 13 would be 52 over 2. 52 over 2 divides to make 26. Okay, so I feel pretty good about that then, okay? All right, next, step number 3. At the first and third quarters, we're going to have y values of a and negative a respectively. So between each consecutive asymptote, if I cut this up into fourths, that gives me quarters, okay? So I've got my first quarter, second quarter, third quarter. These are now quarters. And at the first quarter, I'm going to be at A, where A was 1. So if I go up here to 1, I would be at 1 here. And then at the third quarter, I'm going to be at negative A, which would be negative 1. And then I can connect the dots. And then I can copy and paste that. At the first and third quarter, we're going to be at A and negative A. And then I can make another squiggle. Okay? So then that's what the graph should look like doing it by hand, knowing that this goes to 1 and negative 1. And by the time I get to the end of the second period, I should be at 26 pi. So let's see, answer choice B is out because that's at 2 pi. Answer choice D is not okay. That's at 2 pi. So it's either A or C. They both go to 26 pi. Well, wait a second. Notice that A squiggles up. These squiggles are going up. My squiggles are going down from left to right. So that means it's going to have to be answer choice C. C is going to have to be correct. And just to see if that's right, pun intended, we're going to use Desmos, okay? So to input this into Desmos, we're going to type in COT. Yes, Desmos can do cotangent. 1 over 13 x. Enter. And then what I'm going to do is I'm going to go to my window settings, and I'm going to change the x-axis to fit what answer choice. What answer choice did I say? I forgot now. C. I said answer choice C should be right. And that goes from negative 26 pi to 26 pi. So I'm going to set this to negative 26 pi and 26 pi. And you can change the step to pi if you want. The only thing the step does is it makes sure that your hash marks are labeled in terms of pi. How many squiggles is this? 1, 2, 3, 4 complete squiggles. Answer choice C, 1, 2, 3, 4 complete squiggles. And then notice it goes from negative 2 to 2 on the y-axis. And if I want to change that, I can, just to make sure it looks exactly the same. And then this graph now has the same dimensions as answer choice C, and therefore it should look the same. And it looks really close. So I feel really good about answer choice C now that I've checked it with Desmos. Yay. Now, use the graph to determine the domain. All right, so let's talk about domain again. We know that the domain are the values that x can be, but anytime you have a graph that has asymptotes, you need to consider what can x not be, okay? So we're going to have a domain that says the set of all x such that x cannot be whatever the asymptotes are. Okay, so the first asymptote is at 0. The next asymptote is at 13 pi. The next asymptote is at 26. Notice that 26 is 2 times 13. And 13 pi is 1 times 13. So it looks like we're at integer multiples of 13 pi. Unlike the previous problem, number 7 from the homework, these asymptotes are occurring at every integer multiple of 13 pi. So x such that x cannot be an integer multiple of 13 pi. 13 pi times k, where k is an integer. Not odd integer, any integer, all integers, okay? And that's going to be answer choice C. 13 pi k, k is an integer. And if we check that, we're good. And the range is going to be all real numbers, because notice that these squiggles, these graphs, they're going to go up forever and they're going to go down forever with no break in the graph. So they're going to cover all of the values of y from minus infinity to infinity. Man, I hope that was helpful. If you have any questions or comments, feel free to put those in the comment section below, or you can text me. And thanks for watching.